In this video, we're going to continue our talk with the normal distribution, but instead of just looking at a simple random sample, what we're going to do is we're going to look at sampling distributions. In sampling distributions, what this is taking several samples from a population. And so we have to reevaluate some of our methods for normalizing items. When we're looking at several samples from a population, recall that x bar is the mean of a random sample of size n. So remember that this is our mean for the sample, and this is our sample size. And so when we're talking about the mean of the actual sampling distribution, what we're going to do is we're going to use mu sub x bar. This is that mean of a sampling distribution. So mean of sampling distribution. And really it's no different when we actually look at it. It's actually equal to our population mean. The means are not different. It's the standard deviation that's going to be different. And the reason why the standard deviation is different is the same reason why we calculate the sample standard deviation and the population standard deviation differently, is because of that error that we have to look at and look for. And so the standard deviation for a sampling distribution is going to be sigma of x bar. So this is our standard deviation of a sampling distribution. And how we're going to calculate it is we're just going to take our population standard deviation and we're going to divide it by the square root of n. Again, what this does is it looks for that error or the freedom, degrees of freedom, things of that nature that we want to look at and estimate for and take into account here. And so anytime that you have a sampling distribution that you're looking at, you want to use this standard deviation instead of just your normal standard deviation, because you do want to take care of that error, room for error. And so you want to remember, if you have a sample size, divide it by the square root of n whenever you are actually using that sample mean and everything. Let's look at an example of this. And so the real estate group NY reports that the mean monthly rent for a one-bedroom apartment without a doorman in Manhattan is $2,631. Assume that the standard deviation is 500. A real estate firm samples 100 apartments. So right off the bat, we know that this is our mean. This is our population standard deviation, and we have a sample of n. What is the probability that the sample mean rent is greater than $2,700? So now we're not talking about just one. We've taken a sample of 100, okay? We are still looking at our normal distribution curve, and we're still looking at 2631 being here, and 2700 being here, and it says greater than, so that's shading to the right. So we have to make sure that when we look it up, we do 1 minus whatever value we have, okay? We just have to remember that now when we're doing our z-value, instead of just x, we're looking at our sample mean. and our mean of our samples, divided by our standard deviation over the square root of n now. So now we're still looking at 2700. Our mean was 2631. Our standard deviation was 500. And we had a sample of 100. And I'm going to put this in parentheses so I know to do this division, prior to the other division. And so I'm going to do the subtraction of the 2700 minus 2631, and that's going to give me 69. 500 divided by the square root of 100. Well, the square root of 100 is 10. 500 divided by 10 gives me 50. So that'll give me 50. 69 divided by 50 gives me a 1.38. So my z-score is 1.38. So I'm going to look 1.38 up on my chart. So 1.3 and then an 8. So that's 0.9162. Remember that 0.9162 goes to the left, so I need to subtract it from 1, and I'm going to get 0.0838. So it's going to make our z-scores a little bit different because we're dividing that standard deviation by the square root of our sample size. So we have to be a little bit careful when we look at these. Okay, let's look at one other example of this. Still using the same apartment rent. What is the probability that the sample mean rent is between $2,500 and $2,600? So this time we're going to have to find two z values. We're going to have to find $2,500. Nope, not 2,600, right there. It's going to be our actual mean of 2631, and our standard deviation is 500, and our sample size is 100. I'm also going to have to find the z-score for 2600. Minus 2631 over 500 divided by the square root of 100. So I get z is equal to a negative 131 divided by 50. And over here I get z is equal to a negative 31 over 50. So I get z is equal to a negative 2.62 and z is equal to a negative 0.62. Well, recall that I'm wanting in between. So here's a negative 2.62, which corresponded to my $2,500. And here's my negative 0.62, which corresponded to my $2,600. And so whenever I get my z value, or the probability for this z value, it's going to include everything to the left, all included here. This one is going to include over here. But I want just this portion. So I'm going to have to subtract them out. So if I come over to my z table, I want a negative 2.62. So negative 2.62, so that's going to be 0.0044. 0.0044. And I also want a negative 0.62. So a negative 0.62 is going to be 0.2676. So it's going to be a 0.2676. 0.2676. So I'm actually going to subtract those. 0.2676 minus 0.0044, and I'll get a 0.2632. So the probability that the sample mean rent is between 2,500 and 2,600 is 0.2632. Remember that your probabilities and your areas always have to be positive, so always take the larger number minus the smaller number. That is one thing that we always have to be careful about. Practice some of these with the sampling distributions, with the changing of the z-score, and let me know if you have any questions.